Hey everyone. Okay, so I promised yesterday to upload today a video explaining these problems again. So if you have any doubts, just let me know. Anyway, try to watch the whole video. In this one, they're giving you Fahrenheit and you're searching for Kelvin. So the very first step, your first step is to put whatever you're searching for. In this case is Kelvin. So Kelvin equals degrees Celsius minus 273 as we have it right here. Okay? We don't have degrees Celsius, but you know that you have here a degree Celsius and here the degree Celsius. We're using this one because you have Fahrenheit. So you put Celsius equals Fahrenheit minus 32 times 0.55. Okay? So degrees Celsius equals 5 minus 32 times 0.55. Okay, now in this one it's important to do as a first step this part right here because it's inside the parentheses. So degrees Celsius equals 5 minus 32 will be negative 27 times 0.55. So you have negative 27 times 0.55. You have degrees Celsius of negative, important to put the negative, 14.85. So now you have Kelvin equals negative 14.85 minus, I'm sorry, here it's a plus 273. So you have negative 14.85 plus 273. You have 258.15. And this would be your answer, okay? So just remember to bring this part right here to here. Okay, now in the next one, you're searching for Fahrenheit. So you put your formula. Fahrenheit equals degrees Celsius times 1.8 plus 32. You don't have degrees Celsius. You go to your formulas and you see that you have this one or this one. They're giving you Kelvin. In this one you don't have Kelvin. In this one you do. So you put degrees Celsius equals Kelvin minus 273. So degrees Celsius equals 250 minus 273, negative 23. So you bring the negative 23 here and you put Fahrenheit equals negative 23 times 1.8 plus 32. So Fahrenheit equals negative 41.1 plus 32. And you have negative 9.4. Remember, you may use calculator with these problems. I need only to see the formulas and the substitution. The rest, it can be with calculator. Then in this one, you have 12 degrees Fahrenheit to Celsius. So you will have degrees Celsius equals Fahrenheit minus 32 times 0.55. So degrees Celsius equals 12 minus 32 times 0.55. Degrees Celsius equals negative 20 times 0.55, negative 11. Now let's do this one, Kelvin to Fahrenheit. You're searching for Fahrenheit, so let's put our formula. Fahrenheit equals degrees Celsius times 1.8 plus 32. You don't have degrees Celsius, so you put degrees Celsius equals Kelvin minus 273. Okay, remember always that your first step is to put what you're searching for and then find out what else are you missing. So you have degrees Celsius equals 260 minus 273, negative 13. You bring your negative 13 to your formula and you have negative 13 times 1.8 plus 32. It's negative 23.4 plus 32. And you have 8.6. Now this one we did it yesterday. And then you have Celsius to Fahrenheit. We have Fahrenheit equals degrees Celsius times 1.8 plus 32. So Fahrenheit equals 50 times 1.8 plus 32. 90 plus 32, 122. Okay? Now let's review these ones that we were doing yesterday. I will move to this one. And it says 4.2 joules to kilocalories, because it's a capital C. So you put your box. Let's remember it needs to be in diagonal to be cancelled. So you put joules at the bottom and calories at the top. And you have that in 1 calorie, you have 4.184 joules. So you'll cancel joules with joules and you have calories. But you need capital C. So in order to have your capital C, you will put calories at the bottom so you can cancel and kilocalories at the top. And you know that in 1 kilocalorie, you have 1,000 calories. So you multiply 4.2 times 1, so it will be 4.2 kilocalories divided by, because you already canceled this one and this one, 4.184 times 1,000. There's no unit at the bottom. So is 4.2 kilocalories divided by 4,184, because you multiply it times the 1,000, and your answer will be 0.00100 or 001 kilocalories. Then this one, you have 53 calories to joules. So 53 calories. You put calories at the bottom so you can cancel, and joules at the top. In 1 calorie you have 4.184 joules. And multiply 53 times 4.184, 221.752 joules. Now this one, 6.5 joules to kilocalories. Let's remember that the kilocalories are those you burn when you are doing some exercise. So you put joules at the bottom, calories at the top. In 1 calorie you have 4.184 joules. You will cancel joules with joules. You have calories at the top, so you need to cancel calories here. So kilocalories at the top. Cancel calories with calories. And in 1 kilocalorie, you have 1,000 joules. So it's 6.5 divided by 4,184, just like the other problem. And your answer is 0.00155 kilocalories, okay? Calories would be 1.55. I'm not asking for that, but just to understand more or less how it works. Because you move it 3 times. 1, 2, 3. Okay, now this problem we did it yesterday, but I will explain the next one. How much heat is required to raise the temperature of 12.6 carbon tetrachloride from 17 degrees Celsius to 76 degrees Celsius? The specific heat of the carbon tetrachloride is of 0.85651. Teacher, do I need to put all of these numbers? Yes, you need to put them all in the calculator. So let's start. How much heat is required? So heat equals question mark. For heat, you need a mass, specific heat, temperature 1 and temperature 2 for your delta of temperatures that we talked about yesterday. So you have a mass of 12.6 grams, a specific heat of 0.85651 joules over grams per degree Celsius, temperature 1 of 17 degrees Celsius, and temperature 2 of 76 degrees Celsius. The formula we're using is heat equals mass times specific heat times delta of temperatures. So in this problem, what they're asking you is how much heat will be required, okay, in joules. How much heat, and it will be given in joules. Now, this means that, for example, the Bunsen, mechero de Bunsen will release that heat. So this one can absorb it. So you have a mass of 12.6 grams times 0.85651 joules over grams per degree Celsius times delta of temperatures. Let's remember that delta of temperatures will be a difference, a subtraction, and I need a positive number. So in order to have a positive number, I have 76 degrees Celsius minus 17 degrees Celsius. So heat equals, you start with this part right here because it's the easiest part, and you start also multiplying this one. So you multiply 12.6 times 0.85651, and you have 10.792. You need at least 4 decimal points. Multiply it times 76 minus 17, 59 degrees Celsius. And here I forgot to put the unit. In this case, the unit, you cancel grams with grams, so you have joules over degrees Celsius. And now you multiply this part right here. So you have heat equals 10.792 times 59, 636.728. You cancel degrees Celsius with degrees Celsius, and you have joules. Now, if you want to change joules to kilocalories, go back to these problems, and you'll know how. The next one, how much heat is required to raise the temperature of 895 grams of water from 17 degrees to 98 degrees? So, we want heat equals question mark. We have a mass of 895 grams. We have a specific heat of water, which is 4.184 joules over grams per degree Celsius. Temperature 1 and temperature 2. 17 degrees Celsius and 98 degrees Celsius. So we have heat equals mass times specific heat times delta of temperatures. So heat equals mass times specific heat, in this case, is temperature 2 minus temperature 1, because temperature 2 is higher. Heat equals 895 grams times 4.184 joules over grams per degree Celsius times 98 degrees Celsius minus 17 degrees Celsius. So heat equals 895 times 4.184, you have 3,744.68. You cancel grams with grams, so you have joules over degrees Celsius, and then 98 minus 17 will give you 81 degrees Celsius. So your heat will be equal to 3,744.68 times 81, and it will give you 319.08 joules. And then you can change it to calories and kilocalories if I ask for it. Now this one, pay a lot of attention, because this is more or less what has to do with the project, tomorrow's project. Jim started a cardio workout with a temperature of 36.6 degrees Celsius. After 30 minutes, his new temperature was 37.4 degrees Celsius. His mass is of 45 grams. Important, this guy, Jim, his mass was of 45 kilograms, but I need it in grams, so that's why I changed it. So if you weigh, I don't know, 50 kilograms, make sure you put 50,000 grams. And the specific heat of the human body is 3.47 approximately. That's not so exact because our fluids and everything we have inside. So we have heat equals question mark. We have a mass of 45,000 grams. We have a specific heat of 3.47 joules over grams per degree Celsius. And we have a temperature 1 of 36.6 degrees Celsius and a temperature 2 of 37.4 degrees Celsius. So heat equals mass times specific heat times delta of temperatures. Probably your temperature after your workout will be higher. Let me know if it's different. So you have 45,000 grams times 3.47 joules over grams per degree Celsius times 37.4 degrees Celsius, 36.6 degrees Celsius. Now you start doing it and you multiply 45,000 times 3.47, and it's 156,150. You cancel grams with grams, so you have joules over degrees Celsius times 37.4 minus 36.6, 0.8 degrees Celsius. So heat equals 0.8 degrees Celsius times 156, 150, and it's 124,920 joules. Now, if we want to change it to kilocalories, we have 124,920 joules. You put joules at the bottom and calories at the top. And in 1 calorie, you have 4.184 joules. You cancel joules with joules, and now you want to cancel calories. So small calories, big calories or kilocalories. In 1 kilocalorie, you have 1,000 calories. So you have 124,920 divided by 4,184, and it will give you a burnout of 29.85 kilocalories. Okay, so this guy after 30 minutes of workout burned these kilocalories. Make sure you understand this problem because this has to do with your project, okay? And let me know if you have any doubts. Thanks, guys.